Hi everyone. So today I want to make some pita bread. Now this yeasted dough recipe is pretty easy, and if you haven't made it, fresh pita is way better than the stuff you get that comes in the plastic bag in the supermarket. It's a perfect recipe to bring to a grilling party as well, so you don't have to cook this on a stovetop, you can do it on a grill, and it's maybe even that kind of recipe that you could use to impress a date. So let's go ahead and get into it. So the first thing that we're going to need is a packet of yeast, and to this we're going to add about half a teaspoon of sugar. Now to this, add some warm water and give it a stir, along with about half a cup of flour. Now we want to let this sit for about 10 minutes, and this will allow our yeast a chance to rehydrate and kind of wake up. And we can verify that it's still alive. Now, what do I mean by alive? Like, what is yeast anyways?
Yeast is a general term used to refer to a group of single-celled fungi. And honestly, they're everywhere and come in many different varieties. Yeast are estimated to be hundreds of millions of years old, and it's actually estimated about 1% of all fungi on the planet are actually a form of yeast. These guys are pretty small, and roughly on the order of 3 to 4 microns across, roughly equal to the diameter of a strand of a spider's web.
Alright, now back to the recipe. As it turns out, for the first time in my life, the yeast packet I used actually turned out to be dead, so I kind of had to start over. Now, if your yeast is alive, after about 15 minutes or so, it should look something like this, kind of nice and frothy. Now, if it does, we got the green light and we can keep plowing on ahead. So to this yeast mixture, we can go ahead and add 1/2 cup of whole wheat flour and about 1/4 cup of olive oil. However, if you wanted to, you could also use a different kind of fat here, like maybe, for example, melted butter, go kind of in that non-direction. Now, why are we even using yeast? Well, it's gonna make our bread nice and fluffy, as well as kind of create a lot of complicated flavors as a byproduct of the yeast reaction. Now, you could certainly make a flatbread without the yeast, but how does the yeast even leaven the bread to begin with though?
Well, yeast take in food, output stuff, and reproduce. They have 2 modes of operation, respiration and fermentation. During respiration, yeast feed on simple sugars such as glucose, sucrose, maltose, and fructose, and oxygen and output water, CO2, and energy in the form of ATP, kind of just like us. But when oxygen is in short supply, yeast switch to fermentation, take in simple sugars, and turn them into CO2 and ethanol. At various stages in the bread making process, the yeast we will be using will be switching between these 2 modes, or even doing both at the same time. But in either mode, the yeast are emitting carbon dioxide. And this carbon dioxide, for reasons we'll get into later, gets trapped in the dough and will lift the dough, creating a fluffy foam that we know as bread.
So now back to the pita bread. Next, we're gonna need to add about 2 teaspoons of salt. And I'm just gonna put this whole thing into the stand mixer, and using the dough hook, just put it on the lowest setting and begin mixing. And slowly add in about 3.5 cups of all-purpose flour, just a little bit at a time. If we dump it in all at once, we kind of risk it becoming overly dry and dense. Now, believe it or not, the mere contact of the wet yeast mixture with the flour will set off a complicated chain reaction that has to do with the biology of what's going on with the flour, which comes from wheat and therefore wheat berries.
If you break open a seed, you'll see the various parts. See this fluffy white center here? This fluffy white part, which is the endosperm, makes up actually most of the flour by percentage. The genetic information and kind of control system for the seed is stored here in what's known as the germ, and the whole casing is either known as the seed coat or also can be referred to as the bran. So what exactly is in the endosperm? Well, it actually turns out a lot of stuff, but for this video, we're going to focus on 2 things that are crucial to the bread making process, which are proteins, which will form gluten and give bread its structure, and starches, which fill in the structure and provide a majority of the calories of the bread. We'll get into gluten a little bit later, but let's talk about what makes up the largest percentage of the endosperm by weight, which is the starch. Starch is made up of tiny granules on the order of about 30 microns or micrometers. Starch is not only a good energy source for the plants, but it's also a really good energy source for us. Cooked grains such as rice, corn, barley, wheat, these are all energy sources that are actually really crucial to the human diet. Carbohydrates make up a very large percentage of most people's diets, and this is often why these things are actually called staple foods. They're very important to diet and nutrition in general. Raw starch is a great storage device, but it's just that, a storage device. For it to be useful to the plant, it actually has to be broken down into simple sugars. In the case of the plant, the action of unpacking starch into building blocks is performed by an enzyme known as amylase. Amylase takes the compact starch and breaks it into simple sugars. It lives on the interior of the skin of the seed, waiting to be activated. This is why seeds, when dry, stay seeds for years. However, when they're introduced to water, they'll begin to sprout. When introduced to water, hormones shift, and then the amylase begins breaking down the starch into sugar and gets the plant working towards germination. So how is this relevant to flour? When the wheat berries are milled, the seed interiors are released and the amylase is put into contact with the starch. And when water is introduced, the amylase begins to break down these starches into sugars, which the yeast feed on. Let's set the discussion aside for right now and go back to our bread making.
All right, back to the pita bread. Now I'm gonna take the lazy person's route here, but there's definitely no reason why I couldn't have done this by hand. In total, we wanna knead this for about 7 minutes, during which time we're gonna kickstart the process of gluten formation. And you might have heard a lot about gluten, but what do I mean by that?
Seeds not only contain starch as an energy source, but also the physical building blocks needed for construction, such as proteins. These proteins can be used in a number of things, but in the case of wheat berries, in the endosperm, the main proteins are known as glutenin and gliadin. When in the presence of water, these two proteins connect to each other using a relatively strong bond, and as these proteins connect, they form a chain, and these chains interconnect with each other, forming a network, or a matrix. Essentially, you could think of this as a three-dimensional scaffolding.
Okay, pull the dough ball out of the stand mixer and place the entire dough ball into an olive oil lined bowl. Cover the bowl with a breathable towel or paper towel, and we want to set this into someplace warm for it to rise. During this time, there's a lot of stuff going on, but what is specifically going on?
What are we actually doing here? What we're essentially doing here is we're hydrating the flour. In the presence of water, these glutenin chains will start to bond to the gliadin, forming complex three-dimensional gluten matrices. These chains are initially short, resulting in shaggy dough, and with time and kneading, these networks will get extended and strengthened. These matrices not only trap gas, but also create the perfect nestling spot for those starch granules I spoke about earlier. The presence of these starch molecules will have a deep impact later, and actually, here's an image of what they look like under a scanning electron microscope. You can see the starch is kind of nestled into the gluten matrix.
Now after an hour, my dough kind of looked like this, which is great. So just gently deflate the dough and give it a few folds and let it rise for another hour. Now while it doubles again, let's talk about why we perform those few folds. It may seem non-crucial, but it's actually very important.
Every time we do this, the layers of dough don't 100% overlap, and we're gonna actually trap some small air pockets in the dough. These little air pockets serve as balloons that really can collect the CO2 emitted from the yeast, the basis for the air pockets that we actually see in the final bread.
All right, 1 hour later, after we've deflated the dough, the waiting game is mostly over, and now we can begin forming and shaping the pitas. Now to do this, pull off little globs of dough and roll them into little balls and place them onto a tray. Let them rest for about 15 minutes, which is perfect because this will give us some time to heat up our pan. Now I'm going to use a cast iron pan here because it's a nice heat reservoir and it takes a long time for it to heat up, but it will also stay hot as we toss each pita on. Now heat the pan over medium heat and give it a few minutes for it to really warm up. While it heats up, it's not a bad idea to use the paper towel with a little oil and wipe down the cast iron, or alternatively cooking spray works really well here. This will help ensure the pan doesn't cling to the dough as it cooks. To form the pitas, lightly flour the surface and using a rolling pin, roll out the dough balls into pita-sized pancakes. We really only want these to be a few millimeters thick when rolled out. Now once it seems like the pan is nice and hot, go ahead and gently place the rolled out dough onto the pan and it should start to puff up a little bit. And you should see bubbles on top of the dough. What are these bubbles anyways?
Yeast has converted the sugars from the starch into a gaseous form of CO2.
When heated, these gas bubbles expand rapidly.
We can actually use the ideal gas equation here to explain what's going on. We know that the temperature increase for a maintained pressure and number of CO2 molecules trapped in each bubble, so therefore as the temperature rises, so must the volume. The larger this change in temperature, the larger the volume expansion. So we want to increase the temperature of the loaf as rapidly as possible before the loaf sets. Additionally, as the temperature approaches boiling, water will evaporate and this water vapor will also enter these bubbles, further expanding these bubbles of raising dough.
After about 2 minutes, we can try to pull the dough up and see if it's getting browned. If it is, go ahead and give it a flip and cook the other side. For me, in these types of recipes, the first few don't always work out super well, but by the end, you know, in these kind of batches, you should have some really perfect pitas. I like to keep mine warm under a nice little toasty aluminum foil blanket as the rest cooks, and just keep going through all of them until we're done. And that's it. We've got some nice and fresh pitas. These things warm are an absolute dream, and if you want to tax the cardiac system a little bit higher than is required, you can always add a little bit of olive oil and salt, and I think it makes it a little bit tastier. Now, I'm sorry for tricking some of you into watching a science video, but for those who enjoyed it, I hope you did enjoy it. Please consider subscribing or sharing this video. All right, I'll see you guys next week, and all right, bye.